Okay, so the sum of a finite geometric sequence. The key word here is what?
Sum. Dang it.
Finite. What does finite mean?
Has an ending.
It has an ending. Okay? All we have here is just a sequence. That's it. I don't care about that. Okay. R cannot be 1. If R is 1, it's not a geometric. Multiplying by 1 is not geometric. Just like it is an exponential. Okay? So here's the formula. S sub n, sigma from I is 1 to n. Those are the index, right? The lower index and the upper index of the definition that we worked on yesterday. That's all that is right here, isn't it? Is a sub 1 times the quantity 1 minus r to the n over 1 minus r. That's the formula. A sub 1 is the first term, r is the common ratio, and n is the number of terms I'm adding. Got it? What?
That cannot equal 1 or cannot equal 0?
1. R can't be 1. If r is 1, it's not geometric.
It's just the same.
It's just, yeah. If r is 1, it's not geometric, so it's not.
What is it if r equals 1?
It's not geometric.
It's not.
It's
just what
it's linear. It's actually not. It's linear. If r equals 1, it would be linear because I guess it could be arithmetic because you're just adding a number to it. But okay, everyone got their formula written down? Okay, so we need the sum. I need the sum from 1 to 12 of 4 times 0.3 to the I minus 1. Now, this is how the book will probably write some of them. Some of them they won't. When we write these, we want it just in terms of I, correct? Yeah. We don't want I minus 1. But because they look at the left, it's I minus 1. The right is just what? I. Okay? So we're going to see what the difference is between the two. So we have S sub what? How many things are there from 1 to 12? 12. Okay? If that was 2 to 12, there would be what? 11. Right? So we have S sub 12 equals, how do I find A sub 1?
Plug 1 in.
Plug the lower limit. And I'm going to say 1 is my lower limit, but I plug in the lower limit, right? And the reason I keep saying the lower limit is because does the lower limit have to be 1? No. But this one is, so I'm going to plug in 1. So 1 minus 1 is what? 0. And anything to the 0 is? 1.
My bad.
1 times 4 is? 4. So A sub 1 is? 4. Guys, you've got to get anything to the 0 is 1. That is on like everything. Every placement test, the ACT will happen at least once. It's an important thing. If something was something to the 0 power was 0, would we ever get anything with exponents? No, it'd all be 0. So it cannot be. Okay, so 1 minus, what's R?
0.3.
0.3. Because R is always the base of the exponent, right? What's my N? Yep. Over 1 minus. Okay, so we have to remember order of operations, yes? Okay, so we're going to take it slow. We're going to worry about the denominator. 1 minus 0.3 is 0.7. So we're going to have 4 divided by 0.7, which is 40 divided by 7, right? Because I have to move my... Okay. Well, 40 divided by 7 is not something I can do without a calculator, can I? No. And then I have 1 minus 0.3 to the 12th. So that's 3 to the 12th. 3 to the 12th is pretty big to do, right? We don't need to do that. So we're just going to put 0.3 to the 12th.
Where'd you get the 40?
And the 7.
Because the 7 is right here. This was 4 over 0.7. Yes? Okay?
0.3 to the 12 is 5.31.
Just wait.
Why'd
E
you put
negative
it
7.
under the?
Okay. Since this is multiplication, I can bring this out. Yes? Like, that's basically what that is. It's multiplication, so it can go to either one.
That'd just be 4 over 1.
So without a calculator on your test, your answer is going to be what? That. With a calculator, you are going to put it all in at one time. I don't ever want to see an individual answer there. I want to see one answer. So you would put 40. I would put parenthesis 40 divided by 11 or 7. Parenthesis 1 minus 0.3 to the 12th. And I get, if anyone is checking, I get approximately 5.714.
Yep.
Okay. When we put these things in our calculator, and when I do finally let you start using a calculator on a test, I am not going to take an answer that has been chunked apart. Does that make sense what I'm saying?
Yes.
You have calculators that will allow you to put the whole thing in at one time. You need to put the whole thing at one time. And the only way you're going to get better at that is to do it. Yes?
Yeah.
So you should be doing it now when I'm not grading you on it so you can get better at it and be getting the right answers. The reason I do not let you do like this answer and then multiply them together is you would round this, wouldn't you? Okay, that's rounding once. And then you would round this, wouldn't you? That's twice. And then you would round your answer. Yes? So you have tripled your rounding error. Correct? Now, tripling my rounding error in calculus or pre-calc is not a big deal, yes? But we had a discussion earlier. If I was working for NASA, if I tripled my rounding error, could that be a huge issue? Yes. You have technology that will allow you to round one time should we be using it. Yes. Okay, so now, any different on this one? The next one?
There's I instead of I.
There's I instead of I minus 1. So let's see what that does to it. Okay? So S sub what? 12. Equals?
4.
Nope. Nope. I need A sub 1. How do I get A sub 1? Plug in the lower limit. So 0.3 to the first is what? 0.3. And 3 times 4 is 12, so that'd be 1.2, wouldn't it?
Yeah.
Okay? Already going to have a difference, right? Is anything else going to be different? No.
The answer's going to be different.
Well, the answer is going to be different, yes, but I'm saying the rest of plugging it into the formula. Okay? So that's going to be 1.2 divided by 0.7. So that's 12 divided by 7, isn't it? Okay. So 1.2 divided by 0.7 is 12.7? Or 12. Yeah, can't talk. And then times 1 minus 0.3 to the 12th. So let's see what... to 12, right? I get approximately 1.714. Why is there a difference?
Because
you did one a different way.
Whole number.
Okay.
There's a difference of 4.
Well, sigma is first addition, yes? And the first one we started at where? 4. The second one we started at what?
1.2.
1.2. Should there be a difference?
Yes.
Yes. Okay. So we got to make sure when we're doing it, we're actually plugging in that lower limit to get my A sub 1. Not just looking at it and going, oh, it's 4. Because sometimes it is what you see there. Sometimes it is not. questions?
So,
Oh.
like on 59 here, the n is zeros, and then the top number is 20, so then
How many, what's your A sub n?
that would be 21, right?
Yes. Okay, so use sigma notation to write your sum. Okay, so I need to write a definition to put behind the sigma, right?
Ratios too for A.
Yep. So I need to do like all of it. So Ethan says the ratio is 2 for A. You guys agree? Okay. Go back. Okay, so R is 2. A sub 1 is 9. So that's going to be A sub n equals A sub 1 times 2 to the n minus 1.
You would break that apart, right?
So A sub n equals 9 over 2
Times 2.
to the n. So
Wait, you would put it outside the parentheses?
it doesn't matter, in or out.
Okay.
That's why I did one way, one. Now, if there were more terms in there, it would matter. Like if it was a quantity, like a polynomial in there, it would matter. Okay, so now I have my definition, yes? All I have to do is change this A sub n to a what? What are we writing this in?
Sigma.
Sigma notation. So it's just the sum of 9 over 2 times 2 to the n. Oh, I guess we're using n. You guys want to use I instead? Okay. I.
Yeah.
From I equals what? What's your lower? 1 to what?
I don't know.
Oh, we don't know.
9.
How are we going to figure out?
Yes, check.
Well, plug in the lower
We
limit.
probably have to plug in into this. We probably should set it equal to 1,152 to figure out my n, right?
Why is that big of a number?
Well, because that's the n number.
The upper limits.
The upper limit gave me 1,152, right? So we got to figure out what that n is. So let me see. I'd multiply by 2, wouldn't I? Well, I'd multiply by 2 and divide by 9.
Yeah.
Okay. So that's 2 over 9. Oh, would it be too much to ask for that 9 goes in here? Let's see. 7, 8, 9. No, 9 does go in there. How do I know that 9 goes into 1,052?
Because you just do, because Minecraft math.
If you add it up,
128.
if you add it up,
and
you get what?
9. No,
No.
You get 9. So does 9 go in there?
yeah.
Yes. 9 goes into 11 how many times? Once. With 2 left over?
No.
Not. 9 goes into 25 how many times?
Twice.
With what left over?
7.
7. And it goes into 72 how many times?
8.
8. So I got 182 times 9. Oh, 9, not 9. 2. I'm gonna
256.
come over here with my work because so I got 6, 5, 256
Yep.
equals 2 to the n. So I got to figure out what power of 2 256 is, right? Okay. You guys want to start dividing by 4? 4? Or you want to do 16? Or what do you want to do, 32? I want to do something easy. I'm not using a calculator.
That was 64.
I'm not using a calculator.
What about 8?
8. Okay, 8 is a power of 2, right?
Yeah.
Okay, and 8's pretty easy to divide by. Okay, so 8 into 24, or 25 is 3. 8 into 16 is 2. Okay, so 8 is 2 cubed, yes? And 32, you probably should know it's 2 to the 5th. So I get 2 to the what?
To the 8.
To the 8th.
How do you do math, man?
Okay, so what is n? N is 8. My upper limit is 8. So is it going to take a little bit of work to figure those out?
Yeah.
Yeah. Okay. But they're all going to work out because you're not going to have like a 2.5 n, are you?
You could.
No, you could not.
If you want to, you
I
could.
don't know.
Okay, so it says use summation to write the sum. Well, I did that. Now I need to find the what? Sum? Okay, so I have S sub what?
8.
8 equals,
Lower limit.
nope.
No.
A sub 1. Oh, yeah, I get what you're saying. Lower limit, right? But we have A sub 1, don't we? 9. 1 minus R is 2 to the n, 8, which we do know is 256, yes? Because we just had to figure that out, didn't we? Okay. Over 1 minus R.
2.
Okay. Oh, that's nice. So it's negative 1, isn't it? Denominator is negative 1. So that makes it a negative 9. Okay. So I have negative 9 times, and that's 1 minus 256.
So 255.
So-
255.
Negative 255.
And
Okay, so 9 times 5 is 45. Carry a 4. 9, 4, 2, 2. You guys agree?
2295.
2294?
2295.
Oh, 5. Yes, I put the 4 twice. Thank you. I should have known that was wrong. Okay, so how did we get it in sigma notation? We had to write a what? We had to write a definition to put it in sigma notation.
Backward.
Okay? And your test will be exactly like it was last year, where I give you a list of numbers. I say, write the definition, write it in sigma notation, find this sum, find that sum. I'm going to use one set of numbers to do a bunch of stuff with. But do you have to do this first step to get to the next step? Yes. Okay. Questions, guys?
No, man.
So we're going to do it again. So what do we have to do first?
Find the ratio.
Find the ratio. And I do know that this one is geometric because why?
Because
So it goes from
Negative
positive,
Negative, positive, negative, positive. So if it is anything, it is geometric, correct?
Yeah.
And so we're just going to assume that it's all good. And 3 over 15 is what?
Negative 1/5.
Negative 1/5. And a sub 1 is 15. So we're ready to go, right? So a sub n equals 15, negative 1/5 to the n minus 1. So the minus 1 reciprocates the negative 1/5, yes? Which would be negative 5. So a sub n equals negative 75
yeah, negative 25.
times negative 1/5 to the
And
n. So now we just need to put this in front of a sigma, yes? And I'm going to write it over here. Hopefully I don't run out of room this time. So negative 75 times negative 1/5 to the n. Not n. I. You could do n, guys, but if you do n, make sure you put I down, like you put n in both places. Does that make sense? Okay, so I is 1. Now, we could start this with something other than 1, but why would we? Why would we make it hard on ourselves, right? We're not going to do that. Okay, and we need to figure out what this one is. So how are we going to do it?
plug that in.
Plug it in.
Plug it in. So we have negative 3 over 625 equals negative 75 times negative 1/5 to the n.
Multiply over the negative 75, so that'll be 1 over negative, or
Yeah.
negative 1/75.
Yep. Okay, well, 3 goes into 75, doesn't it?
Yep.
So negative negative is a positive. 3 goes into 75. How many times?
30.
How about 25.
Yeah, I like 3. I was looking at the 3 and it said 3.
Okay. I need to multiply these out, but I really don't need to multiply them out because I'm going to want powers of what, guys? 5. So could I just put it in powers of 5 right now where it's already broken down?
Yeah.
Okay, so this is 5 squared.
And that's 5 to the
And
fourth.
625 is 5 to the 4th, so that's 5 to the 6th. And if you didn't know 625 was 5 to the 4th, you know how to break it down. Yes?
Yeah.
Okay, so we have 1 over 5 to the 6th equals negative 1 over 5 to the n. So n is what?
6.
6. So there we have 6.
Does that negative matter?
No. No. Because if it's to the 6th power, this would be positive. Like your 1/5 would be positive.
Oh, okay.
Yes?
Mm-hmm.
So now what do I do?
S sub 6
S sub 6
equals
and a sub 1 is
15.
15. 1 minus 5 to the 6th over 1 minus 5.
Wouldn't
I'm
you-
gonna turn positive.
How about 1/5, not 5? Sorry. And yes, it will turn. Okay, let me write this so you can see it. Kendra, you're right. The negative 1/5 will turn positive, but we're going to be subtracting it anyway. Does that make sense? And then, but on the bottom, it's going to be turned to a plus, correct? Because a negative. So the bottom is going to be, what, 6/5? So then I multiply by the reciprocal, which is what?
5, 6.
5/6. So 5 times 15. 75, right? So 75 sixths times 1 minus 1/5 to the 6th. And you are definitely going to use a calculator for that, aren't you? You don't have to, but I would. How about you guys?
Yes.
Now, if it was 2, we could do that without a calculator. We could do it all without a calculator, couldn't we? So, but I want to still see the fraction. 5 to the 6th is right here, isn't it? Right here? So 25 times 625. So it would be negative 15624. Anybody second that?
I might have put it in the calculator wrong, but
I think I might have.
Well, I subtracted 1 from it. Oh, no, never mind. Never mind. Don't listen to me. I am so wrong. You were right. Let's just put it all in the calculator one
You
time.
didn't even hear what they said.
I am wrong.
because I got
Y-
12.
I am wrong. I am wrong.
We know.
Students are always right.
That would not be correct, but I will admit that I was wrong here. I get approximately 12.4992.
Yeah.
Yep.
Okay. And why did this get smaller? I mean, why is this getting smaller?
Because it's a fraction.
It's a fraction. And this one's getting bigger, right? Now, I have a question for you. This one over here, R was 2. Yes? And so my numbers are going to get larger and larger and larger and larger. The one on the right, R was negative 1/5. What's going to happen to that number? It's going to get smaller and smaller and smaller, correct? Because the bottom is increasing, the denominator is increasing exponentially.
Yeah.
So what is 1 over 5 to the 9,000th? Give me an approximation.
1 over 5 to the 9,000.
Give me an approximation, guys.
Do it yourself.
Think about it. 1 over 5 to the 9,000ths. What would that approximately be?
0.0018.
No, I wanted you to do it.
It would
It'd be approximately 0, correct?
Yeah.
1 over 5.
1 over 5 to the 9,000th.
Why you just did 9,000?
9,000. Like 9,000 times you're going to multiply 5 times itself. And then divide 1 by that.
Okay. I would
Is that pretty much nothing?
0.
Yes. Okay, so what do you think would happen if I did this to both of these statements? What does that tell you? They're not
It goes on
finite.
longer.
They're infinite, right? And I ask you for the sum. Because this asked you for the sum and they were finite. I ask you for the sum. Can you find the sum on the left?
No.
Why not?
Because it's infinite.
The numbers keep getting infinitely large or small, right? If it was small. But it goes for right? But what about on the right hand side?
None.
What is this number going? What is the nth? It's getting closer and closer to what? 0. And if I'm adding something closer and closer to 0, could I eventually get to an answer?
No. Because it's never
Yes.
ending.
Yeah. I could eventually get to an answer, couldn't I?
Take a while.
It would take a long time, but could I eventually get there? Yeah. And I'm not asking you to write out the numbers. I'm just asking you to find the sum. So what happens is, down here, don't write anything yet. Down here, if I have my equation, and I tell you that 1 over r, or 1 minus r, so that was that negative 1/5 to the n. And since I'm going to increase this n, this number is eventually going to be close to what? 0. So when I plug it in here, it'd be 1 minus 0, wouldn't it?
Yeah.
Well, 1 minus 0 would be what?
1.
It'd just be 1. And I have a formula for finding, and I'll have the formula in a second. I have a formula for finding a finite, but only if what happens?
The
Absolute value of R is less than 1.
Okay, the absolute value of r is less than 1 because r to the negative 2 is just going to keep the numbers are going to go to negative infinity, right? Are they ever going to stop? No. But what about that? Am I eventually going to get to numbers so close to 0 I can't tell the difference? Those are what are known as limits. Okay, our limit is 0, and so it allows me to find this. So your formula for the sum of a finite geometric series only works for finite. Go back. Only works for finite what? Geometric. Okay, arithmetic it never works.
That's
Okay.
infinite.
Yeah, there's a difference.
Oh, it went back. Yes, I'm sorry. Infinite. This only works for infinite geometric. Infinite geometric if r is what? The absolute value of r is what? Less than 1. Okay? Because you will have questions on the test and I say find the sum. And I'm not going to tell you if it's arithmetic or geometric. If it's arithmetic, you say you can't. Your answer is you can't find the sum of an infinite arithmetic sequence, right? If it's geometric, then you have to find r. What happens if r is 5? Can you do it?
Yeah.
Not if it's 5. You say undefined. Absolute value of 5 is greater than 1, right?
Yeah.
What happens if it is negative 1/5? Can you do it?
Yes.
Yes. Or positive 1/5. Can you do it?
Yes.
Yes. The formula is just right here. And it went from a sub 1, because on the other side we did this, right? And then we took and went 0. Well, what's a sub 1 times 1? A sub 1. So that's why it turns into this.
Okay.
Okay, what do you notice different about my S?
There's no.
There's no sub. Why is there no sub?
It's just the sum, it's not the
'Cause
partial.
It's just the sum. It's not the partial sum. A partial sum and a finite sum, are they the same thing? Yes. Okay. The only difference between the two, technically, a finite sum is a series that was finite. A partial sum was a series that was infinite, and they cut it. Can I make something that's infinite finite? Can I cut it?
Yes.
Yes. Can I make something that's finite infinite?
No.
No, because I don't really know what happened. Because I can write a definition for the 6 terms I see, but what happens if that 7th is a little different? You don't ever know. So you can make anything infinite finite, you can cut it, but I can't make something finite infinite. Does everyone understand that?
Yes.
Okay.
I'm not sure I understand.
Shut up.
She knows
My
what's up.
watch doesn't understand. Okay, so again, right here, can I do it at the bottom? It just says, can you do a sum of a infinite geometric if r is greater than, absolute value of r is greater than equal to 1. And I love how they say equal to 1 because if it's 1, it's not a geometric series anyway, so it doesn't matter. Everyone got that equation written down? Okay.
Unfortunately.
So, find the sum. Can I find the sum of the first one? What's r?
And, or 0.6.
0.6.
So yes.
Yes. Okay, so I can do it, right?
Yeah.
So, we just write S. So, a sub 1. How do we find a sub 1?
It's zero.
We plug in
N,
the lower limit.
which would be 0.
Which would be 0.
And it'd be 4 times 1.
It'd be 4 times 1, which would be
4.
4. Over 1 minus,
R.
which is 0.6. So, that would be 4 over 0.4.
Or,
Yeah.
So, move my decimal, right? So, the answer is
4 over 40.
10.
10.
Just Mick, can you explain to me how you got the 4 on top of it? On top of it?
Because it's a sub 1, so we plugged in our lower limit.
Well, yeah.
So 0.6 to the 0 is 1, and 1 times 4 is 4.
Okay.
So that would be the first term.
Okay.
Okay, so the next one's not written, so I need to figure out r, yes?
It's 0.1.
So we have r equals, we take the second divided by the first, and that would be 0.1, yes? If we want to check it, we take the third divided by the what? Second. So we move it 1 and 1, and we still get what? 0.1. Okay, so r is 0.1. So can we do it?
Yes.
Yeah.
Okay. So S equals, a sub 1 is
3.
3. I should have put a parenthesis there because of that point when you have decimals, huh? So you get 3 over 1 minus 0.1.
3 over 0.9.
So 3 over 0.9. So move it. So S equals what?
30 over 9.
10 thirds.
10 thirds.
Why do you get 10 thirds?
You reduced it.
Because you have 30 over 9.
Okay.
3 goes into 30 10 times, and 3 goes into 9 3 times. Am I good to go to the next one? I don't think there's a next one, but there may be. Nope.
Yep, you're good.
Yay.